Did it start?
Yes.
Okay. All right, so yeah, in a commercial a long time ago, there was a Venn diagram, and I kind of laughed. So it was a commercial, a beer commercial. He was saying, like, ladies and beer, and yeah. So this is a Venn diagram. So it's got, like, kind of a flag shape on the outside, a square. Okay, and this is a two-set Venn diagram, two-set or two-circle. So with two sets, you can show different things, and I usually just label them underneath. So if I wanted to show A intersection B, then that's, if this is A and this is B, then the intersection is right here where they overlap, right, where they have in common. And if we wanted A union B, what would that look like? If you have a highlighter, that works nice for these. So A union B is all of A and all of B and both. Okay, so those are two, like A intersection B, A union B. What do you think this one would be? So first of all, what's it saying? So that little prime, remember, means not in A. So if we're not in A, here's A, this circle, so not in A is here and here. It's outside of B as well, so it's like all of out. But we want to intersection, so this would be A prime, would be those two parts. But we want to intersection that with B, and B is here and here. And intersection means both, in both. So where would this be? In the part of B that has those two little symbols in it? Mm-hmm. And so let's think about this. So this would be what we shade. And think about this. This says not in A, but is in B. Yeah. So you could read that like this is not in A, but is in B. So that's sort of how you can think of that. So, like, and is in B, but, okay. So what if I change that to a union? Union and Venn diagrams are so easy. You actually don't even need to think about what this means. You just need to color them all on top of each other. Because union, everyone gets to go. You don't have to compare. You don't have to think about it. You just put everyone, and the overlap doesn't matter. If you color it twice, it's just colored. Right, so you don't even have to look and take away like we did before. If we did A prime, everything not in A, okay, so there's not A. And we want to union that with B. You just draw B on top of it. So what do we do? Color the rest of B. So A prime union B, whenever there's a union, it's just like add A prime to B. Everyone gets to go. You don't take anyone away. So. Intersection, though, you might have to think about it, because it's where they both are. Okay, so if we did a 3-circle Venn diagram, that gets more interesting. We can ask lots more questions. So a 3-circle Venn diagram. So you're going to draw 2. Oh, sorry. You're going to draw 2, and then the third one underneath, okay? That isn't actually a rule, but if everyone keeps it the same, 2 on top, 1 underneath, then it's easier to compare if you're trying to check your answers, or if I'm trying to mark, everyone's got it in the same, because if it's shifted slightly, then it's hard to see if you've got it in the right spot. So this would be A, B, C. How many different regions are there that we're looking at here?
6 or 7?
Yeah, 8.
Okay.
Yeah. So, we could just show A intersection B intersection C would be where? Where they all overlap in that very center, right? But we're going to jump right into more complicated ones. So we're going to say shade. All intersections, first one. Okay, so that's going to be not too hard because you're comparing all of these. Let's call that 1. 2. Union and intersection together, so it makes it a little trickier. And we could put brackets in there. Something like that. So it would say do the bracket first and then compare. So just like when we had the sets written out, 1, 2, 3, or A, B, C, you still use the same rules. So we're going to shade these 3, and it will show you how to do that. So you want to sort of do these in steps. Okay, so for number 1, you can sometimes think about them and reason through it, but if you want part marks, like these questions I usually make about worth 3, but if you have the wrong final answer and you've drawn nothing else, I just have to give you 0 because I can't know what you were thinking, right? So you really should draw them in parts even if you think you can get it in whole. So what could be a part that I would be looking for in this first one? Yeah, and you always start this way, so that would be a logical first start. So if we drew that, A, B, C. So A intersection B is right there, where they overlap. And now we want to intersection that with C prime. So let's draw C prime over here. So C prime is everything outside of C.
So that would include the A, because where A and B overlap, it includes the part where C is.
Right, because if you were, say these were 3 things. Do you own a cat, dog, or turtle? Mm-hmm. And you own both a cat and dog? Mm-hmm. Did it matter that you owned a turtle? Or would you tell me you own a cat and dog?
Oh, okay.
Right? Like, I own a cat, dog, and turtle, but if the question was, do you own a cat or dog, I would say yes, I do. You didn't ask me about the turtle, but so I still fall in that little region, right? Right. But I do own a cat and dog, so I would be in this.
Yeah, our percentage of them could fall into all 3 and would still be included.
In each, right. So whatever the survey is, that's what usually this is showing, different survey kind of results. And yes, I own a cat, dog, and turtle, and gecko.
Wow.
Mhm.
4 rings.
And a fish that the turtle didn't eat. He's about a year old now. The turtle eats fish, but for some reason he didn't eat this one, and it's still living in his tank with him. We say it's his best friend, but we don't name the fish, because maybe one day we'll wake up and there'll be no fish. Because he does eat fish, so just, he likes this one. He might eat his best friend one day. Okay, so what do we want to do with these two drawings? We want to intersection them, so we're looking for where they overlap, where both of them are colored. So where's both of them colored? Oh, this I need to adjust. There. A, B, C. So intersection means both. So they're both colored here. And is that it? And just like you're comparing other sets, look at the smaller one. It can only be here and here. It doesn't matter about the rest. So they're both colored in that part, so that would be the answer. And you can kind of ask yourself, does that make sense? So it's in A and B and not C. Right? Do you see? So you can usually jump to this, but I would say then go back and do a couple little parts. Just in case you mess up, then I can have something to mark. Okay? It's usually worth it. Okay, so let's do number 2. A prime union B intersection C. So same thing, but you would have to, you might be tempted to do B intersection C first because it looks nicer, but you can't because it will give you the wrong thing. You need to do this first. Union is easy. You just add them together, so you don't really need separate drawings for it. You just need to remember that you're just adding those two things together. So that is adding all of A prime, everything outside of A. Okay, so that's all of A prime. So far that's A prime. And we want to union that with C and union, or with B, and union is just draw all of B on top of it. So people don't like that drawing because they see the A prime, so they think they shouldn't be in A. But union is saying everyone not in A and everyone in B can come. That would be union. So yes, part of A prime can be colored in if it's a union. And then we want to intersection that with C. So you wouldn't really need a separate picture of C because you can sort of imagine where C is, but if we did draw a second picture of just C, and then we want to do what to it? Intersection that. So we want A prime union B intersection C. So intersection is look at both and compare. This is compare. And union is add. So where are they both colored? How many regions?
2. Oh, 3.
3.
I'm just not going to answer anymore.
That's okay. You can get them wrong. 1, 2, 3. Kind of weird, that one. And you can't I can't sort of imagine, when it's union and intersection, I find it hard, it would be too hard for me to jump right to the final answer anyway, when you've got those sort of mixed signs. Okay, and the last one. So what's the difference here? We're going to start with the bracket instead.
Yeah, also also the things are different too.
So you might start with B prime union C. And you could do B prime union C all together, because union is add, so you don't need to compare or anything to do that. So all of B prime, this is A, B, so not in B. Union C, so all of C colored in. Everything outside of B prime, and then everything inside of C. And we want to intersection that with A. And it's intersection again, so we're looking at what they both have. So they're both colored here, in the center, and here. Right? So you need to practice a few of these on your own and check if you've got the right answer. There's one on the homework, and then there's more on the practice questions. Okay, so then with Venn diagrams, we're often counting, like how many, like I said, a survey, like this many people have dogs and cats, this many people have dogs, cats, and turtles, or whatever. So there's counting principles to go along with these. But if you're trying to find, like, if you've got numbers in all of these representing how many are in each of the regions, and you need to figure out how many owns cats but not dogs or something, then you can look. This stuff, shading it, is going to show you what regions you need to know. So there is a couple things. One is de Moivre's theorem, which I think is useful. Just useful. So it happens that if you have like A intersection B all prime, you want the opposite of that, it works out to the same as A prime union B prime. So what do? You flip the sign. If you put the primes in it, it flips the sign. So, and this would be A prime intersection B prime. And you could try those by shading the two and seeing that they're equal. It's just on a two-circle Venn diagram, so it's not hard. Like, if we wanted to do A intersection B all prime, just on a two-circle. So A intersection B is where? Just here? Right there. That's A intersection B, where they overlap. So prime would be not there. Right? and then the other side is union, so it's easy to add. You just add them all up. So you do A prime, and then you add B prime to the top of that. A prime, everything outside of A. And this is like add B prime, everything outside of B. And so they work out the same. And the same thing here. Okay, so that's one thing. Sometimes it's useful if you have a prime outside of the bracket, you can put it in and you just change any signs that are in it. And the next is the counting rule. For two sets. So this is saying the number of elements in set A union B. All right, so that's this N in front with a bracket means the number of. Now, I would normally do a survey, just a quick survey in the class. If we can still do it, but the numbers will be silly. So who owns a dog? And me, so 3. So if this was a dog circle, okay, then what number, the whole circle would add up to 3. There'd be 3 people in there out of this class. Who owns a cat? 2. See, can you pretend you own a cat? Okay, so just for the sake of our Venn diagram, say you own a cat. Because, so what just happened is 3 of us own dogs, and 3 of us own cats, a different 3. So you, me, and you, okay? How many people are in the class altogether? 5 of us. You didn't raise your hand either time. Oh, who didn't? Who didn't? You have nothing. Okay, we'll pretend you have a cat. So you would be out here.
Not even a pretend cat.
Right? Yeah, you don't even get the pretend cat. So you're out here, right? You own a cat only, so you'd be in here. And Colin and I own both a cat, dog would be in here. And you own a dog only, so you'd be in here. Right? So if there was lots of people, we would have lots of numbers. So let me just make up some numbers. So 8, 9, 4, 15. Okay? So we'll make up some numbers that are better. So here they are. And so the counting principle is saying this. So how many people are in here altogether? I should have made up numbers that work nice, but what's this? 17, 21, and 15. 21 and 15 is 36. Okay, so we've got 36 people altogether that fall in. Okay, so this is the number in the universal set, is 36. That's everyone. Right? So if we said the number that own dogs, how many would you say that is? No. 17. Right? Because these people are in the dog circle. They do own a dog. So 17 own dogs. How many own cats? 13. How many own... Okay, so if I wanted this outside, you could say this 2 different ways. So I would say, not a dog and not a cat. That would be one way. So, not a dog and not a cat. Is how many? 15? Okay. What else could I ask? A dog but no cat? So how would I write that? So a dog no cat, and no cat is 8. Dog and no cat. And then we could say a cat and no dog is 4. And what's that middle piece? Dog and cat, 9. I could ask lots of questions about it. We usually need to write what the set is. Okay, you don't usually need to write that, but I did want to show you. They are related to what we just did, right? You can sort of see where this piece is. All right, so what's this counting rule up here? This is saying the number of people that own dogs or cats is equal to the number of people that own dogs, so that would be 8 and 9, right? Let's not add them. Let's say, okay, this would be 8 plus 9, the people that own dogs, plus the people that own cats, which would be 9 plus 4. So what happened? How many did we add too many? Right, we've added 9 here, and we've added 9 here, so this is saying subtract the 9 off. The extra 9 that we counted twice. So you can add both, but that meant you counted the 9 twice, so you'd have to take off the 9. So that's what the counting principle says. It doesn't talk about the people on the outside. Right. Now, what about 3 sets? The formula is much, much more complicated because it's longer and you have to subtract things, and actually you might subtract too much. So the counting principle for 3 sets okay, so we're going to write it down. Leave 2 lines of space because it's long, unless you write really small, okay? Leave 2 lines. All right, so let's just give all of these a letter. A, B, C, D, E, F, G, H. Okay? It doesn't matter what the numbers are. I think it'll be easier to see with letters. So if we add the number in A plus the number in B plus the number in C, okay, we'll start with that. Number in A plus the number in B plus the number in C. So let's just write it down here. What would we have added up? So A is what? What letters are in A? A, B, D, E? Okay, that's all of A. And then we would have added, so here's A. And then to that we're going to add all of B. So B plus C plus E plus F. And then to that we're going to add all of C. D plus E plus F plus G. All right. So just using some math skills, let's collect like terms, like how many times did we add A? How many times did we add B? How many times did we... All right, so how many times did we put A down? Just the once, so that's good. All right, so A is just the once. How many times did we add B? 2 times. So let's say 2 B's. Okay. How many times did we have C?
1.
Just 1. D? Twice. E?
3 times.
3. That's that center.
Right.
We added it for all 3. So 3. F, twice, and G, just once. So what do we really want to happen here? What do we want? We just want one of each letter. We want to know how many is all together, just one of each letter. We don't want all of them twice or 3 times. So what did happen twice? Which were the ones that we added twice? Let's circle them. These 3? You can't subtract them off just by itself because that is a complicated expression. What we actually end up doing is subtracting this, which is, this is A and C. So we subtract the intersections. So I'll show you what, so we're going to subtract like A intersection B, subtract A intersection C, and subtract,
Will you have taken all of the E's?
yes, exactly, B and C. Right, so if we do that, we do take off the double of the ones, but we took off E how many times now? We took all three of the E's off, because we took an E off here, and we took an E off here, and we took an E off here. So now, what do we need to add back in? Right. Oops. Add back in the center. That's the formula. So you add each of them, take off each of the intersections, and then add back in the circle. You don't actually need to use this very often, but in some questions, you're not given the very center, but you're given all this other information. So you can find it. You can find the center by using this formula, right? If you know how many own them all together, you would put that number here, each separate one in the intersections, and then you could solve for that. That's when you use that formula. If you're given the center, you can actually reason through it by just filling the numbers into a Venn diagram and looking at it, which I'll show you how to do. So this formula is useful when the center's not given, but when the center's given, you don't need it. So I'll show you what I mean. So we've got this handout. Colin, your homework you handed in the last class has nothing written on it. Oh, okay.
When I turn to this one.
Okay.
A lot better one than nothing.
Yeah, that's okay. I just wondered if you handed the wrong thing in. Okay, so we're going to do these 4, 5, 6. They're definitely numbered wrong. 5. There's no 4. It looks like maybe I had a 4 at some point there, doesn't it? I cut the number 4 out but didn't change the numbering. Yeah. Okay, so we'll just write down sheet. So these are the types of problems we would solve with Venn diagrams. So it says, in a group of 100 students at Big Red's Pizza Emporium, 80 of them ordered mushrooms on their pizza, 72 of them ordered pepperoni, 60 ordered both, and then how many ordered mushrooms but no pepperoni, how many ordered pepperoni but no mushrooms, and how many ordered neither. So can you kind of picture with all the stuff we talked about, right? They're giving us how many sets in this question? How many different toppings are they talking about? Just 2, mushrooms or pepperoni? So this would be a 2-set Venn diagram question. So let's say this is mushroom, and this is pepperoni. Now, once you identify that the question is going to be done using a Venn diagram, then you look for the center piece. And if that's given, then you don't need to use one of those 2 formulas. So is the center given? People that ordered both mushrooms and pepperoni. Yeah, so how many is that? 60. So that's how many go in here. Then you work your way out to the other numbers. So it said, going backwards, for example, 72 ordered pepperoni. So what do we do? This is wrong if I put 72 right here. Right, because there's already 60. So this plus that has to add up to 72. So just 12? All right, so be really careful of that. You don't just throw all the numbers in, because that is way too many people.
It's helpful if they say 100, so total, so then you.
And they don't always.
Yeah, and then if you
Yeah.
write down, you're like, that's way more than 100.
Yeah. So 80 ordered mushrooms, so there's already 60 that ordered mushrooms, so 20 more. And then it says 100 altogether. What does this add up to so far? 92? So we're missing how many? 8. So 8 would go out here. Right, so the whole thing, if you write the 100, it's outside of it because it's the whole thing. And when you write a number in the flag, that would be none. But out here would be the universal set. All of this whole thing should add up to 100. And then we can answer the questions. So A said, how many ordered mushrooms but no pepperoni?
So would you actually write that down as like mushrooms, union?
Oh yeah, so if you wanted to, I would just put the answer.
Would you? Okay.
Yeah, but if you wanted to, then that,
This is helpful to see.
yeah, mushrooms and no pepperoni.
Like how to write it. Sort of thing.
Yeah,
Oh, so it's not union, right? It's
yeah. Pepperoni but no mushrooms? 12? And C, neither. So that's actually not pepperoni and not mushrooms. So 8.
So for Venn diagrams, do you always use the intersection?
Mm-hmm.
Yeah.
I mean, I guess they could say like mushrooms or pepperoni, and then you would use union, M-union, right?
Right.
But usually it's like an intersection. If you're trying to label up one single piece, it's always intersection, yeah. Okay, number 2. So at Dan's automotive shop, 50 cars were inspected. 23 of the cars needed new brakes, 34 needed new exhaust systems, and 6 needed neither. How many needed both? So do you see the center's not given this time? That's when you might use the formula. Because when you do a Venn diagram, you put the center in and then you can subtract your way out. But if they don't give you your center, if they just give you what that the mushrooms were 80, you don't know how to split it up. So that's when the formula comes in handy. So this second one, it says there was 50 cars altogether inspected. 23 needed new brakes. So the number that needed brakes was 23. And the number that needed a new exhaust system was 34. And how do you write neither? Not brakes and not exhaust is 6. So if we were to draw the Venn diagram for that, brakes, exhaust, what numbers out of these 4 numbers can we put in the Venn diagram right now? The 6, because that's neither, so that goes out here. But we can't put the 23 because that's these 2 pieces. And we can't put the 34 because that's these 2, and we don't know how they add up. The 50 is everyone, right? So if we look at that counting principle, the counting rule, let's put B's and E's in it instead. Number in B plus the number in E minus the number in the intersection. Now we do know 3 of these. They're not given explicitly, but it's easy to find. We know B and E. They were given. The union wasn't given. The union is not 50. What's the union? No, that's the intersection. And that wasn't given either. Yeah. If we want a B union E, that's everything in B, adding to everything in E. That's what the union looks like. So the union is these three numbers. If we know the total is 50 and then there's 6 out here, then how many are in the rest of the circles? 50 minus 6, 44 is the union. Right, the union is all of these all together, and we know the whole thing adds up to 50 and 6 are not in those circles. So 44 is the union. So this is 44, B is 23, E is 34, and we want to solve for this one. And just rearrange this. That's negative, bring it over to the other side. So the number in B intersection E is 23 plus 34 minus 44. Just rearranging it. 13. So this is 13. This is 6. And then you can subtract your way out. So B, total of B is 23, so there'd be 10 here, so that adds up to 23. Total of E is 34, so we need 21 here to add up to 34. And then you could just double check that they add up to 50, right? So that's how you would work your way out. You always need that center to start, and then you can put the numbers in. And if you don't have the center, then you have to use the formula. So the questions asked what? How many needed both repairs? So that was the first step anyway. You didn't need the Venn diagram to find that. That was us finding the 13. Number that needed brakes and exhaust was 13. And B, how many needed new brakes but not a new exhaust? 10. Make sense? All right, now 3. Now the first one is really easy, number 3. There's, I think, no subtracting involved. I think I give you all the pieces, exactly where they go. And it's intended to make you be careful next time. So you're going to draw a 3-circle Venn diagram for number 3. Cats, dogs, and birds. Big enough that you can write a number in that center piece. All right, cats, dogs, birds. And I always, just to stay consistent so you can check your answers, I always keep them in the order they're listed in the question. So it said cats, dogs, birds, so I'll go cats, dogs, birds. Okay, so just if you want the same as me, so you don't have to sort of flip it in your mind. Okay, so a class of 40 students completed a survey on what pets they like. So 40 would be the whole thing, all of the numbers added. 10 liked cats and birds, but not dogs. Where does that number go? It actually is right here. It's just representing one piece, so you don't need to subtract. You can put that in. Cats and dogs. Whoops. Oh yeah, cats and birds, but not dogs. The next one, 6 like cats and dogs, but not birds. Cats and dogs, but not birds. 6. So this won't ever happen on a test, that they just go in. but it could happen in real life. Probably they would never list data this way either, right? Two students like dogs and birds, but not cats, too. Two liked all three. 10 like cats only. See, it says cats only, so it's not cats, the whole circle, it's just cats only. Dogs only and birds only. And how many were all together? 40. So how would we know how many like none? Add up all those numbers. I get 40. Oh, I get 40. So what would be out here? 0. So everyone picked at least one. Right? How many students like cats? So 10 plus 6 plus 2 plus 10, 28. And how many liked at least 2 pets? And you couldn't really write that as a set, so just answer it. At least 2 would be what numbers? So that means 2 or 3. They like 2 or 3. So the ones that like 2 is 6 plus 2 plus 10. And the middle, they liked all 3, so plus 2. So 20. I mean, I could write that as a set, but you wouldn't want to see it. You could do all the intersections, the 3 intersections, and then put a union in between each of those, right? So then you would put the intersections all on top of each other. It's just really long. But yeah, you can describe anything, but you don't always want to. Okay, number 5. A survey of 80 neighborhood kids showed that 50 own a trampoline, 35 own a swimming pool. Wouldn't that be a nice neighborhood? Mm-hmm. And 40 own a swing set. 16 own a trampoline and a swimming pool, 11 own a swimming pool and a swing set, 26 own a trampoline and a swing set. Only 2 of the kids didn't own any of the 3. How many kids owned all 3? So, that's saying this one doesn't give you the center. You need to find it. Right, do you see that's, so the whole question is going to take that formula. You may not even need to draw a Venn diagram, because once you find the center, it's not asking anything else.
Right, you can just input it into the number.
Right, it's just asking for the center, so once you get the formula. So we'll write the formula out.
So we have to memorize that too?
Yeah, but it's not hard, remember, so just add all 3, subtract the intersections, and then add back in the center. Easier said than done, right?
Yep, yeah, I would need to practice it.
So you'll fill it all in except this. Basically move the other numbers to the other side and you'll have that. So do we know the union? Sometimes we don't. Sometimes we know the total and how many don't, and then we have to subtract them. So for the union, for this, it's like the number in the universal set minus the number not in any. Right? So it's like, if we know the whole thing, and we subtract out the ones that aren't in the circles, then we have the union. So, how many, there was 80 neighborhood kids altogether, and how many didn't own any?
Wait, can you say that again? What are we,
Well, when you're trying to find this side, just like we did in the other question, the same thing, you're not usually given the union, like all of these numbers added. You're usually given the total, the universal set, and the number who didn't like them.
Okay.
So you'd subtract those 2 numbers to find what all of these add up to,
Right.
which is this. So we're told that there's 80 kids, and 2 didn't own anything. So 78 is this number.
Right, so an easy mistake would just be to let the total equal that.
Yeah. So the number in A, trampoline, we'll call A, is 50, 35, 40, and then the 3 intersections are there, so you subtract those, 16, 11, 26, and then we add back on the one we want. So these are just the singles, these are subtracting the intersections, and we can just work this out. So this is 78 equals 72 plus. So 6.